Hello everybody, in this video we're going to look at standard equations of parabolas when the vertex is at h comma k. So what does that mean? That just means that our vertex has been translated, right? Or our parabola has been translated. So we've looked at previous videos about standard equations when the vertex is at the origin, and I'll link that in the cards right now. But in this video we're going to focus on what happens when we translate this parabola left, right, up, or down. And so just like we looked at when our parabola was located with a vertex at the origin, we're going to look at when we have a vertical axis of symmetry and also a horizontal axis of symmetry. And so that's going to be our four parabola types, right? Ones that could open up, down, left, or right. And we're going to focus on the ones that open up or down right now. And so this is when we have a vertical axis of symmetry, and this is going to be x equals h. So we have a couple diagrams here, and we see x equals h is that pink vertical line, and that's like our axis of symmetry that is going to cut right through our vertex. And it's x equals h because h represents our horizontal translation, that's left or right, just like with vertex form of a parabola, right? That h means the same thing. So if we look at our equation, we have y equals 1 over 4p, so that's very similar, right? P is going to be the value where our focus is located. And then we have x minus h, quantity squared, plus k. All right, so remember, just like vertex form, h and k represent our horizontal and vertical translation. H is like opposite of what it looks like, right? When we plug it in, if we see x minus 1, we're actually going to the right 1. If we see x plus 5, we're actually going to the left 5. K is our vertical translation, that's up or down, and it is what it looks like, right? If we have minus 5, we're going down 5, plus 2, we're going up 2. Okay, so this is also going to adjust where our focus in the directrix is located. So for our focus, the x value of the focus is going to be the same, or it's going to be h, right? Whatever h is, because that's when we're moving left or right. But then our focus is going to be k plus p, right? So k is, h comma k is where our vertex is. And so remember, our focus and our directrix are the same distance from our vertex. And so whenever we figure out our p value, we can just add that to k to get the focus point. Similarly, to find the directrix, we can subtract p from k because that's going to be the same distance away from our vertex as the focus is above, okay? All right, and so that's for this first diagram here when p is greater than 0. We're going to have a parabola that opens up. So our focus is on the interior of the parabola either way, but this would be like above our vertex in this case, okay? And our directrix would be below our vertex. Our second diagram over here on the right is when p is less than 0, so that's going to give us a reflection, a negative value there out at front. And in this case, our vertex, our focus is going to be below the vertex, and our directrix will be above the vertex, okay? But we still get to the focus the same way. We add p to the k value, and we subtract p from the k value to get our directrix, okay? So now let's talk about when we have a horizontal axis of symmetry. So in this case, we have our parabolas that are opening either to the left or to the right, and our horizontal axis of symmetry here is going to be y equals, and this should say k, all right? So y equals k. And we have our equation. Notice we have just switched x and y, but we've also switched h and k. So we got to keep that in mind when we're working with a parabola that opens left or right. So our equation is x equals 1 over 4p, and then times y minus k, quantity squared, plus h. Okay, so k and h still represent horizontal and vertical translation. They are just in a different location. So when we're looking at this equation, we got to be careful with k. Whatever k looks like, it's going to be kind of opposite, right? So if we see plus 1, we're actually going to go down 1, minus 1, we're going to go up 1. And then for h, now h is what it looks like. If we see plus 5, we're going up 5, minus 5, we're going down 5. So now for our focus, we're going to add p to the h value this time, and our k value is going to stay the same, right? So our focus would be h plus p comma k, and very similarly for our directrix, we are going to subtract p, not from k this time, but from h, okay? So we have a couple different diagrams here. When p is greater than 0, notice we have our focus on the right side of our vertex, and then our directrix on the left side, and we're going to open to the right. And then when p is less than 0, so we have some kind of negative value, then our focus will be to the left of our vertex, and our directrix will be to the right, okay? So we're going to look at one example of each of these, and we're actually going to graph one of them today. So for example number 1, we're going to graph x equals 1 over 8 times y minus 1 squared plus 4. So we see that x equals, so you know it's either going to open left or right. Notice that we have 1 over 8, that's positive. So if we go back up here, p is greater than 0, so it should open to the right, okay? So let's take a look and see what we have. So we have x equals 1 over 8, and then y minus 1, quantity squared, plus 4. So we can go ahead and locate where our vertex is going to be. So remember, this would be h, and this would be k in this instance because we have x equals. Okay, so we're going to have a 4, 1 for our vertex. Okay, so we can go ahead and plot that 4, 1. Now we can find our p-value. So this is our vertex. So for p, notice that we started off with 1 over 4p, right? And now we have 1 over 8. So for the p-value, we were 1 over 4p, and we became 1 over 8, right? So what is p? P is 2, okay? So now p is 2. Now our focus is not located at 2, 0. Our focus is going to be located at 6, 1, right? So 6, 1, there's where our focus is going to be. So focus and vertex. Okay, so for our focus, remember if we go back up to our diagram, for our focus, okay, we're going to add p to our h value, okay? So our h value here was 4, and we said p was 2. So for our focus, 4 plus 2 is 6, and our k value is going to stay the same, so that would be 6, 1. Okay, now we could find our directrix. Okay, so for our directrix, remember that's going to be x equals a number, and we're going to subtract p from h. Okay, so once again, h was 4, so subtract, so we're going to get x is equal to 2. Okay, so we can put our directrix in there like this, and now we can go ahead and plug in a couple points to make our parabola. So I'm going to use -3 and 5 because I know that if I plug -3 and 5 in, I'm going to get 4 in those parentheses. When I square that, I get 16. That's going to divide easily with 8. Okay, so we're going to say x is equal to, and actually we're plugging -3 and 5 in for y. So we'll put those here, -3 and 5, okay? So we're gonna say 1 over 8 times, and we'll just work with 5. 5 minus 1 squared plus 4. So we're gonna get 1 over 8. 5 minus 1 would be 4. 4 squared would be 16, right? And 16 divided by 8 would be 2. 2 plus 4 would be 6. Okay, so we have this point right here, 6, 5. Okay. Now, if we do the same thing, we're going to say x equals 1 over 8, and then if we plug in -3, notice how we're going to get the same thing, right? We're going to have 1 over 8, and this would be -4 squared plus 4, which is going to give us the same thing because 4 squared and -4 squared are both 16. Okay, so we get an x equals 6 right here. So now we have 6 and -3. Okay. All right, so now let's draw our parabola through these points here and kind of make it fit a little bit better. All right, I think that's pretty good, okay? And we have our parabola, right? So it's exactly what we thought. It's opening to the right. We have our focus here, we have our directrix there, and we are good to go, okay? All right, example number 2, we have y equals -1 over 24, x plus 6 quantity squared minus 4. So once again, we see we have y equals, right? So it's going to either open up or down. We see this negative here, so we know it's going to open down. So we can start with our vertex, right? Our vertex is going to be located at h, k. So this is going to be -6, -4, right? H and k. So -6, -4, and there is our vertex, okay? Now, let's look at our p-value here. So remember it started off as 1 over 4p. Well, now we have -1 over 24, right? So what was p? P was -6, right? Because we multiply 4 times -6, and that's going to give us -24. So that's going to tell us where our focus is. Our focus now, remember, if we go back up to our diagram for our horizontal, our focus is h, k plus p, okay? So h, so -6, but now we have k plus p. So we have -4 plus -6, so -10, right? So -10, and we have our focus right here, okay? So now for our directrix, we are going to do the opposite of that. So this is going to be y equals, and we were at y equals k, right? So we go back to our diagram up here, y equals k, but now we're going to subtract p. So y equals k minus p. So this is going to be -4 minus -6, or -4 plus 6, and we get y equals 2. Okay, so we can put our directrix right here, And now we can plug in a couple points. So once again, I'm going to plug in -12 and 0 because that's going to give me 6 in my parentheses. When I square that, it's going to give me a number that's going to be pretty easy to work with. So I'm going to say y equals -1/24, and we'll plug in 0 plus 6 squared minus 4. So we get -1/24. This would be times 36 minus 4. So we get y equals, and this is going to give me -5.5 when we subtract there. Okay. If we do the same thing with -12, we'll notice that we're going to get the same thing, right? -12 plus 6, quantity squared minus 4. So y equals -1/24, and this is also going to give me a 36. And we'll get the same thing for y, -5.5. Okay, so we can plot those 2 points to give us our general shape for our parabola. Okay, so we have 0, -5.5, so we'll put that about right there. And -12, 5.5, we'll also put that about right there. Okay. All right, so we'll draw our parabola through these points. Missed them there, but I can adjust this to fit. Okay. All right. Let me get it a little bit more, a little bit up. All right, I think that's pretty good. Okay. All right, so we looked at when we have a parabola where we are having the vertex at h, k, and we're able to graph those, whether they open up, down, left, or right.